Welcome to Digital and FinTech Analytics channel.
Hi friends, welcome back. Uh, so in the last video, we were discussing how we created all these 7 groups and how we converted these 7 groups into uh, a vector of like length 7 by 1 by 11997. So so we understood how these 7 groups were created, where each group is of the length of 1 by 11,997. This represents the number of products that we have. So now we have to assign weightage values, where like the most weightage, uh, the most weightage should be given to this function, this group. This most weightage should be given to this group, and least weightage should be given to the earliest group. How we decide the how we decide which weightage should be given to the which group is basically on the basis of the group or the fractures that has been created most recently, or like the fraction that has been created by grouping the transactions that has been done more recently will be given like most weightage, and the group that has been created by the transactions that were done very earlier will be given like the least weightage. So how we do that? So to do that, it's pretty simple. I will explain it over here. So currently we have 7 by 1 by 11,997, this numpy array. Now what we will do is like we will create a vector. Again, like we'll be creating a vector. Let me do it in a fresh way over here. So corresponding to these 7 groups, we'll be having like 7 vector. 1, 2, 3. So we'll be getting 7 vectors. The overall dimension of which is like 7 by 1 by 11997. Now what we'll do is like we will, for the sake of easier computation, what we will do, and we will also see the same thing in the code. So what we'll do is like we'll reverse this 7 vectors in a way like this one is the most recent transaction, or like the most recent groups, and this is the most earliest group. Now why we are doing like this is basically, once we sort this one in a descending order, where like descending order of the date in which like the group has been created. Why we sort this group in descending order of transaction date is basically we will be creating a weight matrix corresponding to it. So our what we say is known as group decay rate. So the group decay rate over here will be, so we have a group decay rate of zero point 0.7, and we'll start assigning the group decay values of zero point 0.7 to the power 0, zero point 0.7 to the power 1, and so on and so forth to all the 7 groups. Once we have the group decay rate declared, which is like 0.07, we will be assigning the group decay rate where like the initial or the most recent groups will be having like higher group decay rate, and the most earliest group will be having the lowest group decay rate. So if you see like the initial group is having like the group decay rate of 0.7 to the power 0, or which is equal to 1, and as we move towards the most earliest group, the group decay rates keep on reducing, and then we will be doing a element wise matrix multiplication of these two matrices. So so our final vector that we will be getting from, after the multiplications, the final vector that we'll be getting, that will be also of the uh, shape of 7 by 1 by 11997. After multiplying the group decay rate with each of the groups, on the basis of like the earliest groups will be given the least group decay rate, and the most recent groups will be getting the most heavyweight group decay rate. So once we get that, we will be getting this 7 by, after multiplication we'll be getting this 7 by 1 by 997. That's what we will be seeing that is being done in the code. Once we get this vector after multiplication, after group decay rate multiplication, next what we do is like we'll sum it up. So this 7 by 1 by 1197, we'll be summing it up now along the x is equal to 0. So yeah, like we have like this 7 by 1 by 11997 vector, which will be summing it by this x is equal to 0. So the final vector that we'll be getting is like 1 by 1 by 11997, and we'll also normalize it, this value, by the number of groups that we had. So we'll divide it by 7. So that's the normalization step. And the final vector that we got will be like this 1 by 1 by 11997. And what does this represent? So this represents like uh, so we were working on the user ID 2. So corresponding to user ID 2, we are creating a profile by converting all the historical transactions into a single vector. The length of the vector is like 11997. The length of the vector is like 11997. So it will be a sparse vector mostly, because 1197 is the total number of products that is present in the database, and it's not necessary like user ID 2 would have interacted with all the products in the past or in the historical transaction. He would have interacted with few of the products. So those products that the user ID 2 has interacted, those products will be having higher weightage. Say like product number product number 3, 4, 5, 9 that have been highlighted is having like high weightage. So what we'll do is like we'll be sorting these products in descending orders, like the the product IDs having the highest weightage will be sorted in descending order, so that like the product IDs with the highest weightage will be coming on top, and the product IDs with the lowest weightage will be coming on the bottom. So the product IDs that are coming on the top is like most preferential product when it comes to user ID 2, and from their historical transaction we understand like those products, if suggested to user ID 2, then the user ID 2 is more likely to interact with those products and purchase it again. That's pretty much how we recommend products to user from the personalized insight point of view. So let's have a quick look at what we discussed right now using the with the help of the example, like in the coding session. So if you see over here, we are creating a new function known as group decay list, and it is accepting two parameter. One is like the flag value and the group decay list. So the group decay list is what we are getting from these transactions into group size, that we are getting from the output of grouping transactions into group size. Uh, so it's the output. It's the output of this particular function, grouping transactions into group size. So all the groups, all the 7 groups that we created, that needs to be passed into uh, this function. All the 7 groups that we created, that needs to be passed into these functions and the flag values. So here in this function, we'll be giving some weightage. Some weightage like means like the as discussed over here in this particular slide, the groups that are like the most recent groups will be given more weightage, and the groups that are like the most earliest group will be given the least weightage. So how we do that? So first, like by using this particular kind of array manipulation, we reverse this colon minus one, means like how you reverse a list. So if you do colon minus one, the uh, seven the lists, those seven groups of the list are reversed in such a way, like the most recent transaction recent group comes on the top and the most earliest group comes on the bottom, and then we are reshaping it into length of the group decay list, which is basically 7 comma 1 comma minus 1. So we are just reshaping it into 7 groups having 1 by minus 1, means like 11997 products. So in that direction we are just reshaping it. And then um, in this particular piece of code, if flag equal to 2 or else, so depending on the flag, we are assigning the group decay rates. So if you see over here, like if you focus over here, so what you are doing over here is like uh, for x in range of length of reverse sorted list np. So the reverse sorted list np will be of length 7 when the flag is equal to 3 or the flag is equal to 1. So so for those 7, it will range from 0 and it will end at 6. The range of length means like it will start from 0 and it will end at 6. Group decay rate to the power x means like group decay rate is our 0.7 to the power x is coming from x equal to 0 to 6. So we generate like these group decay rates: zero point 0.7 to the power 0, zero point 0.7 to the power 1, zero point 0.7 to the 2 till 0.7 to the power 6 over here. And then we are again reshaping this group decay rate to 7 by 1 by 1. So the dimension of this group decay rate is like 7 by 1 by 1. That's because like we already have like this reverse sorted list np in the of the dimension 7 by 1 by 1197. And when we'll be doing element wise multiplication, we want this group decay rates to be in a array format, or where like the dimension of the array is 7 by 1 by 1. So so then only we can do an element wise multiplication, and that will be much faster. Or else we have to loop over this list and then assign the group decay rate, which will be much slower. So that's why like a numpy is said like to be very fast as compared to uh, the general python. Uh, and and over here like we are simply doing the element wise matrix multiplication of the two two matrices. So once we have multiplied those two matrices, we'll be getting like this value 7 by we'll be getting this 7 by 1 by 1197, that part. And uh, and then we'll be summing up the result by x is equal to 0, that I was saying, right? While we'll be summing it up across x is equal to 0, and we'll be getting our final vector, which is by 1 by 1 by 11,997. And then we'll be dividing it by results dot shape of 0. So result dot shape is basically 7, this number of groups that we had. This is for normalization purpose, and then we'll be returning the final list. So if you see like for user id 2 only, like we had like from the output point of view, if you see like for user id 2 we had like the 7 groups, and each group is of the dimension 1 by 11,997. And the group decay list are this one. These are the seven group decay list. Few are like hidden. We can see six, one is hidden. And then we are reversing it means like we are reversing it such that like the recent group will be coming on the top and the earliest group will be coming on the bottom. And like but the dimension will remain the same. So it's 7 by 1 by 11,997. Then we are creating this group decay rate. The group decay rate, as I was mentioning, is of the dimension 7 by 1 by 1. And like if you see like these values, are like 0.7 to the power 0, zero point 0.7 to the power 1, zero point 0.7 to the power 2, zero point 0.7 to the power 3, until 0.7 to the power 6. So we are creating this kind of uh, this kind of group decay rate matrix. So, and then we'll multiply this one with this one. So that multiplication will be happening in the next step. And after multiplication, the resulting shape is like 7 by 1 by 11,997. Um, and after multiplication, we'll be summing it up. So after summing up, the result is like 1 by 11,997. And yeah, once we have summed up, uh, and after summing it up, this is the final profile for uh, for user ID 2, or like the final purchasing profile for user ID 2. That is like this thing that I was just talking about. The final profile for user ID 2. Once you have reached this is like 1 by 11997. This is same as like this user ID 2. This is the final profile of user ID 2, and this vector represents, like, from personalized insights point of view, whichever products or product IDs or like the indices have the highest weightage, those when recommended to user ID2, the user ID2 is like more likely to purchase that one. So that's pretty much on the personalized insights point of view. This final vector is also known as like the purchasing profile of user ID2. Similar to this purchasing profile of user ID2, we'll be running it for all the users that we have in the database. So yeah, so over here, like, we are passing so over here we can see, like, we are passing group decay list. We are calling the group decay list, and we are passing two parameters. One is like transactions into group size. That is basically transactions into group size. So we are passing this one and the flag values, and we would be running this. If you see, now we will be having like the final list of vectors for all the users that we have. User ID 1, 2, 3, 4. For all the user ID, we'll be having this final list of vectors. So that's how, like, that's pretty much on the personalized insights point of view. In the next lecture, we'll be covering on the collaborative component. That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data-driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.